So, did I not make notes about that? Oh, there's class. I'll keep that diagram. So, I mentioned the word right before the break there, class. And a class is the model that we build our objects from. It's often referred to as the blueprint. The blueprint, the class is the blueprint, and then an instance of the class, the one we're actually using, the thing we made from that blueprint, that's what we refer to as an object. Blueprint or design, for an instance or object. Instance or object. So like a blueprint, I feel it's safe to assume everybody's familiar with American subdivisions, right? You go in, there's a dozen acres or however much of virtually identical houses. Every single house will be kind of unique, right? So let's take a subdivision that is all 2-bedroom ranch homes with a porch and a garage. Typical American house, right? A front yard. But throughout that subdivision, every house in there is a 2-bedroom ranch, but there are slight variances. Maybe some of them have the garage on the right and some of them have the garage on the left. Maybe some of them have like cathedral chapel roof on the porch, the regular angles. Some of them have a flat porch roof. Just slight differences, right? Some of them have a window in the door. Some of them just have a peephole. But they're all 2-bedroom ranch homes. They were all built with the same blueprint. So that's how the class is. Every object that we actually use in our code is going to be slightly different depending on the details we need, but they're all built from that same blueprint or design. They're all built from the same class. Yeah, I think that was the last thing in the notes I was going to talk about. Oh, yeah. And this is what we draw the diagram for to represent in UML. So remember, we have that unified modeling language, the International Standard of Communication, the pictorial-based language, and what we use to represent objects, to fully represent objects, is called a class diagram, which one of your assignments is going to be to draw the class diagram. You can do it in draw.io. They're pre-built there, so all you'll do is create one and fill in the spots. Or in Microsoft Word, just draw a box, or however you want to draw, it's fine. You can use Microsoft Paint or whatever you want to do, because it basically just looks like a box. And there will be 3 sections in it. The top section, which will be separated from the rest by a solid line, is the identifier. Which the name, that the technical term is going to be identifier, but it's the fancy way of saying the name of our class. And then below that, we'll have 2 sections separated by a dashed line. And the first section is attributes or properties. Technically, we would call them attributes, but here starting out, think about them as this is all the variables in your class, just the variables to work with. Those are called attributes in object-oriented when they're inside the object. The things about our object. And then down below, we have the methods, methods or functions, or we could say behaviors. That becomes a useful way to think about it. So this is, and all our functions get listed down here. So you'll have to draw one of those. There's an example of them in the book. Well, we're getting ready to do a dog object. So we'd have, or an animal object. So we'll have the identifier is going to be the name of the object. So it's going to be animal.py. Again, it's going to be a Python file. Then a solid line to separate that from the properties we put in it, which is the example I just pulled up on my tablet here. So we're getting ready to follow this. So it's going to have a name, age, and sound that it makes. And then it's going to have a behavior of making the sound. We'll have a method to make sound, which is just an echo of whatever, echo out whatever is in the sound, proper sound attribute of it. So it'll look something like that, just a quick description of it. And we don't really use them in Python because we don't have private stuff in Python. But if you continue on, there are a couple other symbols that you would need with these. I'll put them over here. A plus sign means it's public. So like on the donut picture I drew a moment ago with encapsulation, the plus sign is that outer circle. A minus sign to indicate it's private. So in Python, everything is actually public. So we would put a plus sign before it. Or if we're in a language where we actually have private stuff, a minus sign indicates private. The pound sign or hashtag to represent abstract, which you will see in abstract or virtual, depending on what class you take for your 200 level. You'll see that there. And static, if we have static things, we underline them. And we're not really getting into it. Static means there's only one copy. So like our math object that we've been using, whenever we need some of the things in there, like math.floor or math.ceiling, math.abs for absolute value. Those are all static methods. That's why we have, and we ask for the class name. That means a lot more in other languages. Python doesn't really distinguish those the way it is in other languages. I just wanted to go ahead and mention what the symbols mean on UML diagram. If it's accessible from the outside, a plus sign to indicate it's public, or a minus sign if it's not accessible from outside our object. If it's abstract, which means it's the idea of an object, but it's not quite enough to put together. It's most of the things like for a geometric shape object, we know we'll have a get area method because that's something all of our geometric shapes are going to have. They're going to have an area. But until we get to the subclass of that, where we know which area we need, right? Because the area of a circle is very different than the area of a square, and the area of a triangle, or the area of a pentagon, or a hexagon. All of our shapes are going to have a different area formula. So in the parent class, we know we're going to have a get area method because all shapes have an area, but we won't know what it is until we get more details. So we would just set that up as abstract which means it has to be filled, those details have to be filled in before we can actually use it. We won't see those here. I was just including them for the UML diagram so that when you see, if you see those on a UML diagram, you know what they mean. Oh yeah, I put a note at the bottom. Also, if you used Raptor in your SDEV 120 class, the flowchart diagram, if you go in object-oriented mode in Raptor, it will make some really nice looking UML class diagrams. So if you want to put your class diagram together there, you can just open Raptor if you still have it and go to mode and switch to object-oriented mode. And the screen, main screen you'll be looking at, if you right-click and choose the new button, you'll put in a new class diagram. Then when you click on that, you have options to add in all the stuff about it. The attributes and members is the term they use there. I guess we could look at that really quick because we're about ready for our example. And that is in the assignment. And it, might as well include that because it makes really nice looking UML diagrams if we just want to use that. And another thing is the UML class diagram, those, a computer can generate those all day long. And usually a human just needs to organize them. Right? In a big piece of software, we're going to have lots and lots of classes. So we need a way to organize our class diagrams and draw all the arrows between them so that they look nice. It looks nice and it's easy to follow. A computer can generate them, but it can't organize them for us. So typically we have the computer organize them for us. So if you want to, for that assignment, if you go in Raptor, if you put it in object-oriented mode, if you still have that, on the UML tab, you just right-click and create a new one, a new class, and then just kind of fill in the spots. So like give it a new name. We're gonna do an animal class. And then if you right-click on it, there's this option to edit members. And you get this little dialog box where you can put in all the blue one is a field. So that's going to be all your attributes or variables. And the pink one is the methods. And then you can put the diagram together that way, have lots of nice little arrows to connect them and things like that. So that is one quick and easy way to get a UML diagram if you still have that from your SDEV 120 class. Figured I'd point at that. But yeah, so that's the international standard of communication, how we represent those. I'm going to erase this half. Is that okay?
Yeah.
Yeah, just the diagrams. There is one due, but there's software that will draw them. If you used draw.io before, that's a popular schematic site. I guess I could have shown that one as well. There is a shape for a UML class diagram that you will just drag over and then start putting words into. So it's very easy to use as well. There's lots of software to put it together, but I think by this point, you all know I'm kind of laid back. So if you just want to draw it on a piece of paper and send me a picture of that piece of paper, I'd be fine with that. I'll figure out what it means when I grade it. So for our example, to apply those concepts of encapsulation and inheritance and polymorphism, I've come back around my examples and got back to animals. So, well, way up at the top, we have that thing object in Python. And I'm just going to draw these with some little bubbles. So inheriting things from object, we're going to make this object called animal. And there's certain things about an animal, the ones I put in the example here that I'm getting ready to copy from, have a name, an age, and a sound. So we're going to give each animal a name, an age, and a sound to make, which we'll probably go ahead and set in a default sound, but we don't know what the animal's name or age is until we get a particular instance of it. Right? On a blueprint, when we look at a blueprint for ranch homes, the ones I was using earlier, we don't know how old a particular ranch home is, right? Maybe you're living in a subdivision, like I would describe, with the 2-bedroom ranch homes that are all slightly different, right? All of them have a porch. Some of them have a garage on the left, some of them on the right. Some of them have a half basement, some of them have a full basement. They're all a little bit different, but they're all written from the same blueprint. So if you wanted to know the age of a particular house in there, the blueprint is not going to give you the information of that house, right? You're going to have to check a different record about it and check when that particular house was built. So that's kind of the difference between the class and the design. We're just going to put something in there that says we have an age for an animal. But until we go to use that in our code, we don't know what that age, the age of a particular animal is going to be. And actually, it's going to be different for everyone we use. And then we'll make a couple different types of animals. So inheriting from that, one of them will be a lion. And well, a lion, we don't necessarily need to do anything specific for it, right? We'll have a name for it, give it an age, and our default animal sound will probably just be roar, which will work fine for a lion. So we don't have to do anything for that. But another animal is we could have a cat. And again, it's going to inherit this stuff. So the name, age, and the ability to make a sound will be fine, except that our default animal sound, like I just said, is, I might as well write it here. The default animal sound is going to be roar, which doesn't really work for a house cat, right? They might think they're roaring at us, but we interpret that a little bit different. So we want to override that. Sound equals meow. I can't remember if I've said it before or not. The term override, you've probably heard that in lots of movies and stuff. I like to refer to it as the most misused word in Hollywood. Override means change the default value. So actually, when you're watching, next time you hear somebody in a movie say that, in order to save the day, say they're going to override something, just imagine that character saying, I'm going to try to change the default value. And it kind of makes it comical how they always use that word in Hollywood. But we're going to override that sound for the cat because we want the cat to say meow, not roar. Then our third example will be a dog. And just to cover everything, the open-close principle, this animal object will be closed for modification, but it's open for extension. We'll extend it into this dog object and add another property. So something about dogs, we can add in the property wears bandana. So along with the make sound property, we'll have a property about a dog saying whether or not it's wearing a bandana, just to add something in there. And then once again, we'd probably want to overwrite our default sound for a dog. So that the sound for a dog, we'd overwrite that to a woof, I suppose. Does that diagram make sense of how these things interact? So then if we have some code that we're going to use where any random animal would work, like all we need is the age of an animal, any of our animal types would work. And that's polymorphism. So something that confused me for the longest time is notice which way the arrows point here. We usually refer to these arrows when we're talking about inheritance, but it's pointing back up. And that confused me for the longest time, that the arrows point the direction of polymorphism. So if we need any random animal, like all we need is the age property maybe, then a lion would work. So a lion is polymorphic to an animal. So that's the direction the arrows point. But most often we think about them when we're talking about inheritance. And that we can do that because a lion is going to inherit all of these properties from an animal. Same thing with a cat and a dog. We customize them to fit our needs. So that's the example we're getting ready to make. Hopefully it'll make more sense when we see it in code and put up a couple sentences, but it does take a little while to get used to. It's somewhat different, but before we open up Python and start typing, are there any questions?
No.
Okay, so I'm going to go ahead and share my screen and open up idle. Go ahead and open up idle. And create a new text file to work in. What font size was I using? Was it like 18? I'll try that. Everybody see that okay?
Yep.
Or that size? Okay.
Yep.
Nice big text on the screen. Make sure it comes through clear. So we want to design some classes that we can make objects out of. So I'm going to start with this, do this picture. That's why I drew that. So everything automatically inherits from object. So that very top bubble in the picture, we don't necessarily need that one. We'll start with our animal class. So our keyword for that is going to be class, and then the name of the class we want. And we don't have to specify that we're inheriting from object. So we don't need anything in parentheses. We can just say we're creating this class called animal. And then what I feel is the standard Python notation, the keyword, the reference we're going to give it, and then a colon, and then all the stuff about it will indent to indicate it's inside of there. And the first thing we want to do, I already erased it from the board. I think I meant to leave that up there. Those three methods that we need. We need the init method, the equal method, and the string method. We want to include those, and then we'll, along with the specific stuff we need. So first thing is we always want to do the init method first. And all of these have two underscores. So define underscore underscore init underscore underscore, and then we'll need some parentheses and start typing what's in there. But we do need to put stuff in parentheses. So when we do call the init method, the initialization, actually every single method we write inside of a class, the very first word has to be self. The very first parameter we fill has to be self. And then when we create an instance of this class, our actual object, the object we pass in is the first parameter in every single method we write. At some point, I'm going to leave it off one of the methods, or if I forget to leave it off, I'm going to come back and delete it from a method so we see what the error messages looks like. But the very first thing we pass in, the first argument in every single method, the object has to refer to itself. It has to pass itself in to fill the first parameter of every method we write. And then after that, we can pass in the stuff we need. So, like I said, or put on the board there, every animal, we're going to give it a name, and we're going to give it an age, and that's going to be unique for every single animal. And we're also going to have it make a sound. And I'm going to go ahead and put a default sound in, and by default, every animal just says roar. And we can override that if we need to, the same way we did anytime we defined the function 2 weeks ago, I think, when we went over that. We put in the default value, and if we want to change that, we can just pass in an argument to fill that parameter. And it will use the one we passed in instead of the default one. And these two that we did not put default values on, we want to make those required. So anytime somebody asks to use an instance of our animal class, they have to pass in a name and an age, because it just won't work without those parameters. But anything else we want, we're going to go ahead and throw in some, make optional. There's default values to start with on most stuff. And now to access, to rewrite these, we want to use the word self everywhere. And we can put it directly, so we'll use self and then the dot operator, which we've seen quite a bit, right? Like when we imported modules. When we import the math module, we'll say like math.floor. Floor is just something about that math library. And the same thing here. So the dot indicates something about this self object we're working with. So we could access this directly and put name, but to give it a little bit of, well, in most languages, we can say it's private, and then we're the only ones that have access to it. It can only be accessed from inside of the class. In Python, we don't really have a private method, but we do have this double underscore thing. That means something to the interpreter. So it's fairly standard that if we want our variables or attributes or properties to be treated as private variables, we'll start with 2 underscores. I'll get that cursor out of the way. Underscore, underscore. And then that tells the interpreter what to do with it. It's semi-static, but we just generally treat that as a private variable. So if you see somebody else's Python code where a variable starts with 2 underscores, just treat it as a private thing. So we're going to, the dot operator kind of is like about or inside of. So this self object we're creating, one of the things inside of it is a private field. It's not really private, but I'm going to use the word private for the rest of the lecture because we're going to act like that's private. And it's customary that if you see that in somebody else's code, treat that as if it was private. So we have this name, this private name attribute for the object we're creating, and we're going to assign it that thing name that was passed in. And those do not have to match. We could have called this in and then set self.name equals name. But even if we didn't do the 2 underscores, those only look the same to us. They look nothing alike inside the computer. They only look the same to us, so the computer would never get confused between them. So it makes the code a little easier to follow if we use the same reference on both of them. So self.name is name. And we also have this private field called age, which is going to be set to that age thing we passed in, and the sound it makes. So self.__ sound is going to be set to that sound, which is either a default unless we decide to override it later. And now we can set up some methods. So we said those are private, which means they're only accessible to us. They're only accessible here inside the class. But if we want somebody else to be able to access it, we do want to provide a way for them to get the name of this animal. So we'll add another method in here called getName. And this is fairly standard. Our technical terms are going to be accessor and mutator. So you might see those words on a multiple choice quiz or a certification at some point. An accessor is a way to access the value, and a mutator is a way to change that. But when we're talking, we just say getters and setters. So it's fairly standard to write them in camel case across different languages. So like get name, we want to get the name variable. And obviously to get the value of that name, we don't have to pass in any parameters explicitly, but we do still need the object ourselves. This has to be the first parameter in every single function we write about this class. So get name, basically it's like get name of the self. And then when we go to call it, maybe we'll have, our particular instance, we're going to call it Fido. Then we'll do Fido.getName. So really putting self in parentheses here is kind of like saying self.getName, because that's what we're going to use when we access that method. So we do have to put that first everywhere. And for a getter, all we need to do is return that value, this name attribute, but the name field we put here is directly connected to this self object that we created. So we want to make sure and return self.__name. And usually we want getters and setters for all of our variables that we're going to change. Unless it's something we want to make sure there's no way to be changed. In that case, we would just leave, we wouldn't, if we don't want it to be changed, we just don't provide anybody else a method by which that can be changed. But typically we would go ahead and do a get name and a set name. And for the set name, well, once again, the first parameter has to be the object we're working on. And the next one is obviously what we want to change the name to. So we could call that new name or something if you feel that's more descriptive. And then it's just a reassignment. So we'll grab the self__name field and reassign it this name variable, this name value that we pass in. And Python won't, but most IDEs will generate all the getters and setters for us. Most every IDE and most of your languages, after you list out what data fields you have, the variables that can be used that are encapsulated in our objects, after we list those out, we can usually push, well, it's fairly standard to have Alt Insert. If you push Alt Insert key, you can just generate all the getters and setters automatically. And it saves a whole lot of typing. And avoids chance of a typo because the computers don't make typos, except early in the debugging stages. So by the time we use that, it's not going to make a typo. And we might as well do that, getters and setters for all our variables. So define a what's next? Get age. And we don't need to pass anything in order to ask for the age that's stored there, but we do have to say it's part of the self. And then it'll look the same. So we're just going to return that self__age value. And might as well give a way to set that. Set age, the self, and the new age we want it to be, which again is just going to set that self_age value data field to the new age we passed in. I'm going to add some space here. There we go. That way I'm not working at the bottom of the screen. So ways to get and change all of our values there. And if we don't want that to be changed, we could just leave off the setters, right? Maybe we want to protect the age field, so we could just not put in a set age method so that there's no way to change that age data field. Might as well do the same thing for the sound. Define a getter for the sound which again is just going to return that data field. Whoops. And a setter for the sound. Whoops. I was talking and typing at the same time, sorry. That should have been the word self in those parentheses. Hopefully you noticed that if you were following along. Set sound, we need the object it's referring to, and then whatever the new sound we're going to set it to is. So self.__sound is equal to that thing we just passed in. And now we need ways to those other two methods, like the equals method. Define ___ equal. We need a way to compare this. At the very least, we want to be able to say, yes, they're the same, or no, they're not the same. I think I'll just use the age. That seems an easy way to compare it, right? We're going to compare our animals based off the age. If they're the same age, we'll say they're equal. Otherwise, they're not going to be equal. So we need the self. And then we'll need the other animal we're comparing it to. So obviously, we need that thing we're going to compare it to. So then we can check and see if self.age is equal to animal.getAge. Because that animal is going to be the same class. It's going to be something from the same class. But over there, oh, whoops, I forgot the underscores here. Over inside of, and we're only working on the self one. So if we need another one, such as this animal object that we're passing in, we can't directly ask or directly access the __age data field. So we have to use the getter for the other one because we are outside of that other one. And then we want to set up a string, a default string method. __string. Pass it in the self like normal. And then just what is a good default string for this this animal. So here we have access to these, so we could ask for the data field itself, but we're going to use this in our child objects a lot more. We have this animal object is going to be the parent of a lion, cat, and dog object, and those are the ones we're actually going to use the most. So those aren't actually the ones we're working on right now. So they don't have access to that ___ variable. So it's much better form to go ahead and use the getter, because the child will have its own getter. It will inherit like the get name method. So then we can we can use the get name here. Since we already created it, we can go ahead and use it, and we won't. And the child will have its own get name method. So we want to make sure and use those when we set up the strings. So what's a good default string? I'll do return self.getName, called the getName method, plus is plus self.getAge. These pictures are in my way. I have to move the videos. There we go. Plus the self.getAge method, plus years old. I'm going to come down to the next line. Backslash plus. So it's like Fido is 4 years old. What else did I put there? Just and the sound. And goes plus self.makeSound. So that just gives us a default string to represent our animal object. Does that kind of make sense?
Yep. Mm-hmm.
Okay, so some syntax stuff. So then we can create an animal object. So Control S, I'll go ahead and save this. And I'm going to send this one out. So over here in my delete folder, I'm going to create a new folder called, class example. That doesn't look like a folder. Oh, there it goes. And this will be animals. Whoops. Oh, yeah, I'm in Python. I thought I forgot the .py. So now that we have that, we can use this class. I'm going to create a new file. That was way bigger than I wanted. I guess I'll just make it smaller. Whoops. That way I can still kind of flip back and forth between them. And here's where it's going to be used. So for one, I'm going to have to import this other module in order to use it, right? And I'm going to put them in the same folder, so we won't have to do anything special. We can just import it. It's in the same folder. It'll be able to find it. So I'm going to import that animals module that we made, and then I'll create an instance of the animal class. So I'm going to call the first one thing because we don't know what type of animal it is. Some random animal. But it will be the animals module and the animal class, and then we need to pass in some properties, right? So this one is implied. This one is kind of internal. That one will be filled automatically by the reference we set. So any place over here in our class that we wrote the word self, for this object, that is going to be thing now. Any place we wrote self is now going to be filled in with thing. And then we have a name, so we need some sort of name for it. Buddy, that's a good name for an animal if we don't know what it is, right? Usually start off with, hey there, buddy. Then an age for it. I don't know, I'll just throw in maybe 4, some sort of name, some sort of age, and it's just going to make that default sound. So I'm going to save this. I'll call this zoo. Zoo.py, just a collection of animals. So we have this one class where we define all the stuff about animals, this module and a bunch of classes. Well, one class in it right now. We're going to put more in there. And then we have this other program where we're actually using those objects. So now we have an object, which is an instance of a class. So we have this object called thing we can do stuff with. So I'm going to go ahead and run the program and get those over here in the interpreter. And the pictures are in the way again. I'll move them over here. I guess I could have put a print method. Well, first off, I'm going to print thing. So if we just ask for it, we get it tells us what it is. There's this animal.animal object at some spot in memory. And then we can access those properties we built in. So we can do like thing.getName. And we see the name we put in there. Thing.getSound. Get the sound that it makes. Or we worked in that object where we could cast it to a string. And I was talking the whole time, so I have a feeling I put got a typo here, but nope. Oh, I forgot to do some casting when I concatenated things. We've seen that before, right? So that's internal. But if we tried to add that to a print statement, well, actually, we'll do that here in a moment. Where's the other class? Close out of this. I'm going to put in those things we did. So what did we do there? We printed thing to see what it was. And then we can print thing.getName, which the name is a string, so there's no problem printing that. I'm save that. And over here, yeah, I was talking the whole time, and age is a sound. Or, sorry, age is an integer. I was looking at the words when I said that. Age is an integer, so we have to cast that into a string in order to concatenate it. Whereas the sound is a string and the name is a string, so we don't have to worry about casting those. So I'll save that. Go back over to the class, to the module where we're writing things about them. Maybe if I put the pictures here, that'd be out of the way. So if we save this and run that again, self, where'd my class go? When I was getting ready, I called the getter make sound because those words made more sense. But here, when we put it together, I just called it get sound. That's what that error was about. It can be dangerous to talk and type at the same time. See what happens now? Remember the first time that we said ask to cast that into a string, we said just put the print method to ask for thing. It gave us that. But when we put print and then pass in thing, well, it's calling that overloaded separated one that automatically does the casting and all that. We've seen that on the print method. It automatically casts that into string and gives us that default value of what it is. Then what's the second one? When we printed, yeah, the second line there said print thing.getName. Oh, I forgot parentheses. So this is what we saw with those when we had a function, right? If we just put the function name in without putting parentheses, it would just tell us there's a function at some spot. But here, our function is directly connected to that object. So it's saying it's a bound method, and it's bound to that animal object we created. Which notice this one's in a different spot in memory than the one earlier. Then here, the next time it called it up, it's at the same spot in memory. So that's where it's stored at in memory in case we need those. I meant to put the parentheses here. That's a function, so we have to actually put the parentheses there. So I'll hit that and rerun it. Oh, save, yes. Whoops. That's why I didn't save. I thought I hit Control S, but apparently I just hit S. So now when I get name method returns the name. So most of that should seem somewhat familiar, right? We've seen variables and functions before. It's just sort of a different format. And we stored that under with the variable underscore underscore name, right? So thing dot underscore underscore name. If we try to access the underscore stuff, the interpreter won't let us. That's why we treat them as private. We can't directly access it. It's semi-static, so we have to access it from the class. I think it's animals dot animal dot underscore. I think I need a couple more underscores here somewhere. Is that it? Nope. Animals dot underscore underscore animal. There is a way to access it. We have to access it directly from the class, though. And I'm drawing a blank on what it is, but it's something like this. For where we're at in this class, we just don't, we want to treat those as private variables. So now I'm concerned because I can't remember what that was. We hardly ever access stuff that way. Maybe it's, I need something like this. Well, I can't remember how to access it. I will, when I send the examples out, I'll type in how to access that directly. I'd have to look it back up. I know I have it in an example somewhere, but not the example I have pulled up on my tablet. And it's something we very rarely do. That's why I can't remember, but it's somehow we have to ask for the class name. We'll ask for the animal object, and there's some underscores around it. And then we can access this part. But I'll have to look that back up, and I'll just add it in when I send out the examples later. Don't need to waste time on that now because it's something we shouldn't do, but I wanted to include how to do it at some point. So that's just kind of some things about this object. It has all the stuff we need. A name and an age. So, yeah, a simple example, but everything our object needs is included. The name, age, the sound, a way to initialize it, create an instance of it, and a way to print it to a string. And our syntax looks something like this. So we have a reference. If we use this style of import, we have to refer to the module. We've seen ways to import that where we don't need the name, but then we ask for the class we created, and in parentheses send arguments to fill in any of the parameters we'll need. But like the picture on the board has, I was going to get a little bit more specific with some of this. The inheritance thing. We want more specific versions of these. So afterwards, notice my cursor's all the way back out at the outer indent level to indicate we are finished with that class, the whole Python thing. I'm going to make another class called Lion. So the keyword class, and I'm going to call this one lion. But there's one other thing about this one that the first class didn't have. Our first class was like the starting point. So after we gave the name, we jumped right to the colon. Here, we need to say that the lion is going to be a child of the animal class. And we do that by putting it in parentheses. And then our colon. So lion will get everything about the animal object. And looking at these, I think all of these are going to be good for a lion, right? We're going to pass in the name and the age. And the sound roar seems appropriate for a lion. So we don't, there's nothing really to do here. But we can't leave this blank. So we need the keyword pass. That just means there's nothing to do here. A lion is a subclass of animal, but there's nothing specific about a lion. A lion is like our generic animal. It's just a more specific object we can ask for, but it doesn't add anything to the parent object. But now we can come over here and do that same stuff. I'm going to add a row of comments in to separate it. But we can make a lion. What's a good lion name? Oh, Simba. That's a good lion name. It's going to be from the animals module. It'll be a lion object with the name Simba, 3 years old, and that should be good. So if we print that, print Simba, we save and run that now. I don't think we've seen the word pass, have we? So yeah, that just means don't do anything. Okay, yeah. Yeah, it means, yeah, anytime we just have to have something there, right? We can't leave this blank, but there's nothing to do. So pass just tells the interpreter keep going. Nothing to see here. So if we print that, when we run it, what it should have. Did I skip a step there? Did I forget to save something? I can see it right there on the screen, so I don't know why it says it's not there. Animals has no attribute lion. Back in here. Oh, I think I spelled it correctly. Why is that not pulling anything up? Line 15, Simba equals animals.lion. I'm not seeing my the typo I made here. Did I spell that right? Go paste, save that. I'm running this one directly. So there's no errors there. L equals lamp. Oh, that's how we access it. Underscore, underscore, yeah. So if we do underscore, underscore, yeah, it should be 2 underscores, then dot the object. That's the one I couldn't remember earlier. Sorry. And then we type all that in, and then we have access to it. So it exists. Why did that not import?
Either it's a plural. Animals supposed to be animal. Like it's supposed to be not plural. Is that right?
That one should be the class name. So the lion is in the animals file. And then animal is just one object in there. I'm going to retype it. I don't see what I'm doing wrong here. Actually, let me rerun that. And I'll try what I just did here. L equals animals.line. Okay, it worked that time. Maybe there was a typo I just wasn't seeing. So Simba equals animals.lion. Um, 3 years old. Print Simba. Okay, there it is. Sometimes our eyes will lie to us. If you all have never seen that, there's that most famous example. Like they say we can all see our nose all the time. Our brain ignores it. But our eyes are really bad about lying to our brain about what we actually see. And I think that might have been one of those situations. My brain knew what was supposed to be written there, so it just saw that instead of what was actually there. You can see now we got back that same string. Everything in the animal object was inherited by that lion object, and we were able to create another instance of it. So we can reuse this code over and over again. I'll do the same thing I did up there. So print Simba.getName, or print Simba.getSound. And we have a way to reassign it, right? So we can call like Simba.setSound to what was that thing in the movie? I have no idea how to spell it. Something like that from the Lion King movie. I know what they said. I remember what they said, but I'm sure there's some extra letters in the spelling there somewhere.
I think it's like Mut, M-U-T-A-T-A. Yeah, it's something like that.
Yeah, something like that. Whatever they were saying in the movie. Simba changed what he was saying at some point. So print Simba.getSound. And we saw from where I couldn't remember that earlier, we don't have access to the sound __ sound data field or variable. So in order to change it, we have to use this set sound method. We run that. And you see, we were able to change and adjust it to fit our needs. But a lion fits all of those properties that we have from the animal object. Nothing changed. But on other things, something might change. So like the next one is just a cat, like a house cat. Again, it's going to inherit everything from animal. But this time we're going to change stuff. So we don't want to just call pass. We don't want to say don't do anything. We're going to change stuff. So we need to define a new init method or initialization, which again is going to take the self. And we have to spell all of this out because it needs to match. We have to pass all of this stuff back up to the parent object. So we need to make sure and take those, that we're set up to take those in. Take in a name and age. Only this time the sound is different, right? For house cat, we're going to say meow. Just kind of trail off instead of the exclamation points. And that's the only, whoops, I forgot the colon. And that's the only change is our sound is different. And then we can take all of these and pass right back up to our animal object by using the keyword super. So we're going to call super with parentheses afterwards because it's a method that is saying that is the function that means call the super method, and then we're going to access its init method, and then pass whatever we got for name. We're just going to pass right back up. Whatever we got for age, we're going to pass that right back up, and then we're going to pass the sound back up because we already changed that default here. Does that make sense? So it should look a whole lot like what we did over here with our, when we needed a method about the super object, about the object, we did the object dot set sound, but when we're in it, a child of that object, we'll refer to the parent by calling it super with parentheses afterwards, and the child has access to that init method from the super. If we put the word, if we put that keyword, we can access those things in the parent, like the initialization. And I think that's all we need to change there. If we wanted to, alternatively, instead of taking in the sound here, we could have just left the default sound the same and just manually passed it in here. We're going to overwrite that by saying meow down there. Those do the exact same thing. The only difference is we stored it to a variable before passing it back up the first time. And that should be enough for the cat object. Everything else is stuff that we inherit from the parent object. You see how we don't have to write all this stuff again? We wrote it once, and then all these subclasses of animals inherit all that stuff. So we can reuse this code and make changes to it. We can we can't modify this one, but we can extend it as a child class and then modify that child. So that open close principle. I need some white space here. White space for scrolling. I just don't like working at the very bottom of a screen. That bothers me for some reason. So I'll put in another little separator and make a cat. Fluffy, that's a good name for a cat. So Fluffy is our animals module, and then we created this cat object, which I don't think I saved. Make sure I hit Control S so that we have that. And then it's named Fluffy, and maybe Fluffy is an old cat, like 12 years old. And then we still have all of those things we have, like the cast to a string method. I'm going to do a slightly different one. So I'm going to put in a string. So like, who's that? Ask a question. Add a couple spaces. And then plus Fluffy. So this one's going to cause a problem. When I run it, we'll see. Should see an error message we've seen a few times. Oh, there we go. We've seen that a few times, right? Only now, usually when we see that, it says we can only concatenate string, not float or not integer. But we have the same thing here. We can't concatenate a cat because a cat is not a string. But if we call our cast to a string on it, oh, actually, let me type that in again. If I call the cast to a string, notice that string casting method is set up to work with that object, the grandparent object, the thing everything inherits from. So that's how we know our object will already work with that string method because of polymorphism. We're down here in a cat object. A cat object can also behave as an animal object. That polymorphism, many shapes. A cat can also be an animal, and an animal can also be an object. And that's where that comes in important. Becomes important because then when we set up our methods, we need to use polymorphism. Right? Like we're setting up this library of animal things, but when we write methods to work with them, we might not know whether we have a lion or a cat or a dog being passed in. But we would know that all of those are child objects of an animal. So if we wrote our methods to work with an animal, we know everything in that library would work. And that's what the object here in the prediction thing is. We know everything in Python inherits from that object, the object class way up at the top level of inheritance where it all starts. So any method we write, if we plan it to work with objects, we know it'll work. So I'm gonna cast that into a string, and when we run it again, I'm gonna close this because that filled up very quickly, and run that again. That way I don't have to go moving stuff on the screen. Oh, there we go. And see, that time we got our toString method from that casting. So that's what that str method, it actually works with the thing we put in our objects. It looks for this. That's why we want to put that in every single object. Let's make a couple more cats. Fluffy, what are generic cat names? Whiskers is an animals module. The cat object, we call him Whiskers, and he's a kitten, or yeah, a kitten. He's like 1 year old. And then I didn't know the name for a cat. I can't think of too many generic cat names. I can think of lots of cats I've known. Oh, Sylvester from Looney Tunes. Whoops. So Sylvester is also an animals.cat, a cat object, which we need the animals because it's in that module. And then we need the dot. That's what I was saying earlier. When we create a module that is an object, that's why we can access the things in the module the same way we can access like this method in that class. Because everything in Python is an object. But usually when we say object-oriented, we're talking about the class stuff. What do I call him? Sylvester. And to test that other method we haven't looked at yet, I'm going to say Sylvester is 12 years old. Because we also have this equality method, right? So now we should be able to do some comparisons. So like if Fluffy is equal to Whiskers, print Fluffy.getName plus matches plus Whiskers.getName. And I'm going to copy all that. Copy, go back and type else, print is not the same as. So it kind of ran off the side of the screen there, but did y'all see what I did there?
Yeah, yeah.
Yeah, so we have that equality method so we can tell if they're equals. And I just decided age seemed like a good place to compare them. So if we run that, we see that Fluffy is not the same as Whiskers. But that was kind of a lot to type, so I'm going to copy the whole thing and do a comparison to Sylvester. And notice how we don't have to keep rewriting that same code. We have more than one cat, so they're going to use the same code over the same programming that applies to them. So we still have to think like programmers, all the stuff we've been studying and that doesn't necessarily come intuitive to put our classes together. But once we have our objects, interacting with them is a lot more intuitive because that we can think of them as, oh, wait. Something went wrong there. Those should not have been the same. I have to use is. I may need the key to do that for equality. Is not the same. Is that not what I did? Oh, I forgot the return. If they're this, I guess I got started talking because we have to actually make that comparison, right? If those are the same, then return true. That probably makes that should make a lot more sense than what I typed there originally, right? We actually define what the equality means. Sorry, I must have got distracted while I was typing that. Now let me try that. Make sure I save that, and with the full definition of what equality means there, and run that. There we go. So now, when we make that comparison, it looks at their ages, and if they're not the same age, we don't count them as the same. But Fluffy and Sylvester were the same age, so they do match. Sorry about that. I'm not sure what happened. That was a while ago. That was like 45 minutes ago. I'm guessing that was one of the cases of the dangers of talking and typing at the same time and being easily distracted. But we do have to fully make the definition, fully define what it means for them to be equal. And actually, that should make a whole lot more sense than what I wrote there the first time. Sorry about that. Not sure where the drifting off came from. I have one more object I was going to create. This one will go a little bit quicker. Because I wanted to also show the expansion. We've seen one that's just an exact match of the parent and just a better name to use, right? That's when we would want to do something like this. If it's exactly like the parent object we're using, but there might be a better name that makes our code easier to follow and stuff like that, then we'd want to create something like that. We were able to change some of the default values, but we haven't seen any actual expansion yet. So I'm going to make a dog object that inherit again as a child of the animal object, animal class, sorry. And I'm going to add something to it. Dogs often wear bandanas. So I'm going to add that in as a property about a dog. So we're not going right with the parent. So once again, we need our init method. And we'll do self. We always need the self first. We'll pass in an age, sound. We might as well go ahead and override that here. Dogs are going to say woof. And I'll add in another property called bandana, which I'll go ahead and set to false by default. So the dog either wears a bandana or it doesn't. So once again, we'll call the super method. We'll pass a whole bunch of stuff back up to the animal class and go to its init method, and we want to pass in the name, the age, and the sound. But then there's no place for the bandana to be passed back up. That field doesn't exist in the parent. That's only here. So we can add it on here, self.__ bandana. I need more white space. There we go. Is equal to, and yeah, equal to that one that was passed in. Sorry, I just got distracted. I don't know if you're the Smithsonian Museum. One of their current exhibits is the history of the bandana. And I saw an article about it, and it was actually way more interesting. That it surprised me how interesting it was. Just there's like a long history about that, and it's a very big part of American culture. So sorry, that just kind of distracted me for a moment. Typing that word, but it's another property about a dog. So we have all the stuff from the parent object, but because of this new property, we need some things for that new property, right? We'll need a getter for it. Get bandana, which is a true or false value, so we'll return what it is, just like we saw when we wrote the getters and setters earlier. Set bandana, because maybe that changes later. And in that case, we'll just take that bandana field and reset it to the one we passed in. Oh, yeah. Oh, well, I'll use this as the example of leaving that off. Remember I said the self parameter needs to be the first thing passed in. So here I'm going to leave that off so we'll see the error message that shows up. And that way you'll know how to recognize that error message if the self thing is left off. Equality, we can use the same one. I guess we should do something about that, the toString, and add the bandana in that. So overwrite the string method. And for that, we'll return basically the same string. So I'm going to copy the one from up here. And then add in plus does not, does, we haven't seen that notation, have we? It's already been a while. I'm going to add another method in here. Define where's bandana applies to itself. If bandana, which is a true or false value, so we don't really need to make any comparison to it because that holds true or false itself, then return does wear a bandana. Whoops. Else return does not wear a bandana. And then we can just call that method down here in our toString. Plus where's bandana? Self.where's bandana. That other notation that I started to put there, we will look at that sometime when it hasn't been 3 hours of class already, and it'll stick in your mind because it's a very useful thing. It puts an entire if-else structure in one short line, so it can be really useful for strings and things. But it's already been 3 hours. We've seen a lot of stuff, so let's just stick with the one thing for now. So there is a problem with this one because I didn't pass in that self method here. So I wanted to look at what error that throws. That way you'll recognize that when you see it. So I'll come over here, add in a dog object here. Fido equals animals dot dog, which is going to be called Fido. That sounds like a young dog's like 4 years old. And bandana equals false. We'll set the bandana attribute to false on it for him. And a dog called Sparky. And we'll start dog. That sounds like a puppy. And bandana equals true. And we've seen most of this stuff. Well, I'll just do this one first. So Fido dot get name, and I left. Remember this. Well, we know this is missing the get bandana. That's the one. I left that out of get bandana. Remember the self parameter we pass in here, that refers to the object itself. So that's referring to Fido here. So this is going to throw an error, and just to see what that error is, it's a type error, and notice our hint here. It says it takes 0 arguments, so it doesn't expect any parameters to be filled, but 1 was given, which seems a little confusing because if we look at our code, we did not put any arguments there, right? We didn't send anything, and it says the problem is one thing was sent. So when you see that, that indicates we left off this, because the self thing does get passed in automatically. So if it says you have the wrong number of parameters and it doesn't match up what you see in the code, that's an indicator you left the word self off there. Save that, or here's save that, run that again. This time that should work. Uh-oh. Did I spell that wrong somewhere? Oh, yeah, I left an N out. Now it should run. Oh, and make sure you save everything every time, especially if you're working in more than one file. Oh, I guess I should print that. Print Fido get bandana. There we go. So he didn't wear a bandana, so it returned false for that one. And I guess the last thing in this example is I'm just going to print out those two objects. Print Fido, print Sparky. Uh-oh. String takes 0 position. So that's saying I forgot the self thing again, right? To take 0 positional arguments, but 1 was given. Well, if we look at the code, it's showing there's nothing there. But anytime we see that message, that means we forgot the word self. Excuse me, we forgot the word self. Save that file, and run that. Uh-oh. It should be, oh. Yep, it's starting to get late because we do not have a variable called bandana anywhere in here. We had a local variable called bandana that we passed in here, but we immediately moved that into this place, into a data field, self.__ bandana. So that's what we should be checking here. I just overlooked that one. Did I already clear that error message? Yeah. So whatever that error message said, I think it said there was nothing called bandana. So remember that once you're in your object, you have to refer to the one you're working with. Like that was on whichever one came first. So that came in the Fido object. So we have to throw in the word self to refer to that it's to that Fido object that we'll actually be using in our code. I hope I saved that. There you go. And we can see the adjustments to the string there. 4 years old and goes woof. I guess the word and should be in there. The standard debugging, right? We run stuff and see if it works. Add a backslash in plus, and then that wears bandana thing. There we go. That fits a little bit better. So that was kind of the introduction I had in mind. Any questions about that?
No, not really.
All right. Yeah, and it's an active subject, so you're going to want to do this. The main thing, it's incredibly useful, but when we're first learning it, it does seem like a lot of extra work. But also, this was a very simplified example. What your book has to introduce them is very simplified examples. So at this point, it's going to seem like extra work, but it is worth it. So even though the simple examples introducing it are going to make it just seem like a lot of extra work, it is worth it in the long run. So you'll just want to practice with it. Remember the self object. And yeah, so the homework has a couple objects and draws some diagrams. I will send those examples out here in a few minutes. And our textbook, one thing that I wasn't exactly happy with from the textbook is they do a very brief introduction to objects. And then for the rest of the book, they use object-oriented stuff, which makes it all the rest of the stuff become extra confusing. So that's one of the reasons that I wanted to push back the other chapter on graphical user interfaces. We didn't get around to talking about it this week, so I'm going to push that back till next week. So I changed the due dates on the homework. But the book, does one chapter introducing objects, and then everything it does about GUIs with the TK interface, it does with the class notation, which actually seems to make it a lot harder and is not at all necessary for any of the examples they use. So when we talk about that on Monday, we will do it without the class for our GUI. We'll move back to just the regular variables and methods like we've been using all semester to hopefully make that and make it seem a little easier than what the book does. Because that's not my favorite point about our textbook. They give a good explanation on objects in that chapter, but then they turn around and everything else for the rest of the book, they only use the objects, which clutters up and makes things more complicated because a good introduction is not enough to suddenly do everything that way. You kind of ease into it. But for this week, so yeah, basically just the object-oriented stuff. And then we'll talk about the GUIs next week. Any questions?
Nope, none.
All right, so that was it for tonight, and you'll want to mess around with it. And if you're interested in doing a little bit of video game stuff, that's when I really learned to understand object-oriented programming, was when I started putting together video games, because it's much easier to visualize everything in that game as its own independent object that interacts with other objects. But otherwise, that's it for this evening. If you have any questions, let me know. And everybody have a great Thanksgiving.
You too. I'll see you next week.
See you next week.